So up until this point, we've learned 3 different ways of solving systems. The first one from 6.1 was solving by graphing, where you find the point of intersection, and that's your solution to the system. The second method was solving with substitution method. That was section 6.2. And yesterday we did 6.3, which was solving with linear combinations, also known as elimination method. So today's section, 6.4, is really just putting them all together and being good at deciding which method is best according to the system. So you're not always going to do elimination method. Even though I say elimination is usually the fastest, the best method, you're not always going to use that. For example, right here, they are both in slope-intercept form. That means they're ready to graph. And even if you don't have graph paper, since they're in slope-intercept form, look at them and recognize that they have the same what? The same
y-intercept.
Y-intercept value, the B value, right? You guys remember y equals mx plus b? They have the same B value. So just by knowing that, I know that my answers are going to be 0, 2. Just by knowing that. I don't have to do any math whatsoever, right? Now, yes, I could have modified these equations, changed them to standard form, and then I could have thought of eliminating either x's or y's. But why would he do that if they're both in slope-intercept form and he could both clearly see the B value? Now, if you're still wondering how the heck did he get the answer 0, 2, it's this simple, guys. When you graph it on the xy plane, the top equation on a graph in blue, it crosses at 2, and from that point you go up 2 over 3. Okay? So you end up right here. There's your blue line. And the bottom one on a graph in red, it also crosses at 2, but in this case you're going to be going down because it's negative, down 5 over 3. So if you did go down 5, 1, 2, 3, 4, 5, and over 3, you'd end up over here. But the bottom line is you're looking for that point of intersection, which you could clearly see is the coordinate 0 on x, 2 on y. So whenever it's in slope-intercept form and you have the same B value, you already automatically know your answer. You don't have to do any math. You don't even have to graph it. I mean, unless you're totally lost. But it's like a free point, guys. And I promise you, it will happen on at least one question on Friday's quiz. How about this guy? This system, y equals negative 2x minus 7, and y equals 5 6x minus 7. If I tell you solve this system, what's the answer going to be without doing any math? 0, negative 7. Easy, right? It's so easy. Yes, question. How do I know that? Because I look at them and I see that they're all in this form, y equals mx plus b, right? So I see that both of them have the same B value. And B value is where you start graphing. It's the y-intercept value, right? So I already know that both the top equation and the bottom equation are both going to cross at the B value of negative 7. Oh, yeah. So it's a fact. They have to. They both start right there. They're both going to cross. That's the point of intersection. So that's like a free point, guys. There's only 15 questions. As of now, there's only 15 questions on the quiz Friday. One of them is going to be this easy one. That's over 7. That's like 7% right there of your grade. Super easy. Just instant, no math necessary. It's not the only type. It's not the only type of slope-intercept form or graphing that we're going to be doing. Look at this one right here. It's also in slope-intercept form. Right here, the answer is not the B value because it doesn't have the same B value. What do we know about these two equations? They have the same slope. This slope is 2/3. This slope is 2/3. What is slope? It's a steepness, right? You rise 2, run 3. So if they're both going in the same direction, what do we know about these lines when you graph them? They're parallel, right? If they're parallel, they're not going to intersect, which means that there is no answer. So no solution is the correct answer there. I promise you there's going to be at least one of those out of the 15 on Friday. So right there, no math involved also. Now, if you don't understand why it's no solution, I mean, think about graphing it. The top one crosses at 5, 1, 2, 3, 4, 5. Crosses right there. It goes up 2 over 3. There it is. The other one crosses at 2. It goes up 2 over 3. There it is. So you end up with parallel lines, which means that they never cross, which means no solution. So are we always going to use elimination method? No. If they're in slope-intercept form, think about the graph. You might have the same b value, which means that the b value, the intersection, is at 0 and the b value. Or they may be parallel, which means that they have no solution. Is this one ready to graph? Well, the bottom one's ready to graph, the top one's not. I mean, you could use x and y intercepts. So on this one, I think substitution would be best, right? It has y by itself. Let's take this value, plug it into the y of the other equation we haven't used. As a matter of fact, that's the only time I would use substitution, when you have y by itself already, or x by itself already. That's the only time I actually would choose to use substitution. But anyway, that top equation is going to become 3x plus y equals 12. Now, instead of plus y, I'm going to be plugging in that negative x minus 2. Let me ask you this, guys. Is there any number to distribute? No. The plus sign, if you distribute it, it's not going to change anything. So we're going to have a new equation that reads 3x minus 2 equals 12. Let's combine like terms. 3x, take away x. It's going to be 2x's. Let's bring down the minus 2 equals 12. And let's continue solving. To get rid of the minus 2, you're going to do the opposite, plus 2. Plus 2. We're going to end up with 2x equals 14, which means what? X equals 7. So far, in our ordered pair solution, we have 7 being x, right? The x value is 7. We still need the y value. How do I do that? Plug it in. Which one would you like to plug it into, top or bottom?
Top.
Bottom.
Okay.
Negative x minus 2. I mean, you could plug it into the top if you want. I think the bottom one's a little easier. Let's plug in 7 right in there. That's really just a negative 7 minus 2. So y equals negative 9. Ta-da! So there's your ordered pair, 7 comma negative 9. Of course, on Friday, you will have some time left over. Don't turn in your quiz if you're done. You should go back and plug in 7 for x, negative 9 for y, and see if it works on both. That way you could double check and be absolutely certain that you're going to get an A on the quiz Friday. So again, we're not always using elimination method. We learned yesterday that elimination method is awesome, especially if it's already ready to eliminate. But sometimes, if they're in slope-intercept form, we think about graphing. Sometimes, when the y is by itself, you plug in with substitution method. Now, up here, it's not in slope-intercept form, not in y equals mx plus b. They are not with the variable by itself, ready to substitute. So right here, yeah, let's use elimination method. Okay. As a matter of fact, this is probably one of the most challenging types of systems because you actually have to modify both equations, not just one. So let's get rid of either the x's or the y's. What do you say? X's. X's look a little bit easier to get rid of. I need to get this to become a certain value and this the exact opposite value. It would be nice like if this were a 2 instead of a 3. That way I could convert it to a 4, which will cancel out with a negative 4.
So 4 on the top.
So since we can't convert one number to look like the opposite of the other, we're going to modify both. We're going to make the top one become a 12x and the bottom one become a negative 12x because it's already negative. So the top one we're going to multiply by 4. The bottom one we're going to multiply by 3. Okay, so let's multiply the top one by 4. We're going to get 12x. 4 times 3 is 12. 4 times negative 6 is negative 24y. 4 times 9, that's 36. Bottom equation, 3 times negative 4 is negative 12x. 3 times positive 7 is positive 21 with the y. And 3 times 16 is negative 48. Wait, this seems familiar. I think we already did this one yesterday. Let's continue working here. The x's are, the system is now ready to combine and eliminate the x's. So what do I have left? Negative 24 plus 21, that's negative 3 with the y. equals 36 minus 48 is negative 12. If you're confused with the negative numbers, please use the calculator on the quiz. Let's get rid of that multiplication of a negative 3 by dividing by negative 3, dividing by negative 3. Y equals positive 4. I still need the other value. Let's plug it back into any equation to find the other value. Let's go with the top one. 3x minus 6 times y equals 9. But I'm going to plug in the 4 that y equals right in there. So I really have 3x minus 24 equals 9. And I get rid of that minus 24 by adding 24 to both sides. So I will get 3x equaling 33. So the final step would be to divide by 3. Divided by 3, x equals 11. So the ordered pair answer is parenthesis 11 comma 4. And of course, double check your answers when you're done with the quiz. 11-4. You always put the x before the y. That's why it's called ordered pair. It's alphabetical order. X comes before y. And it's a pair of numbers. Likewise, if you didn't have x's and y's, if you had c's and d's, or q's and r's, right, you put them in alphabetical order, always. Now, sometimes, oh, well, we skipped this one, huh? My bad. Let's do this one. How would I solve this one? Are they ready to combine and cancel?
Negative 1.
See, right now, if I combine them, I get 4x. It doesn't cancel. If I combine them, I get 7y. It doesn't cancel. So yes, you need to modify one of them. Let's modify the bottom one by multiplying by negative 1. Top one's going to stay exactly the same. Bottom one changes to a negative 2x, a negative 2y, equaling a negative 6. Multiply everything by negative 1. Change all the signs. Then we're going to combine the lines, which causes the x's to eliminate after modifying it. We'll have a 3y equaling negative 9. And that's a simple one-step equation. The answer is what? Y equals negative 3. So again, we want an ordered pair solution. So far, the y value is negative 3. We still need to find the x value. So let's plug it into the bottom one. So 2x plus 2 times y equals 6. We're plugging in the negative 3 right there. It really reads 2x minus 6 because 2 times negative 3 is negative 6 equals 6. And then I get rid of the minus 6 by going plus 6. Plus 6, 2x equals 12. Final step would be to divide by 2, x equals 6. So 6 comma negative 3 is the correct answer for this system. And of course, if you have time left over, at the end of the quiz, please test them. Plug in the 6 for x, 2 times 6 is 12. Plug in negative 3 for y. 2 times negative 3 is negative 6. 12, take away 6, it really is 6. You can do that with both, verify it with both, and you'll be absolutely positive that you're getting the correct answers. Okay, so where are we at now? Oh, I'm sorry. Okay, sorry about jumping around the worksheet. So what do you think this one's good for? Elimination method or substitution method or graphing? Substitution's good. I'm going to take this guy, plug it into the other equation I have not used, and into the y. And I'm plugging into y because it says y equals. If it would say x equals, I'd be plugging into x. But it says y equals, so I'm plugging into y. So my bottom equation is going to be 2x minus y equals 2, but instead of the y, I'm plugging in the 2x plus 6. And right here, we do have that minus sign to distribute. So let's distribute the minus sign, put it right in front of the 2x, and put it right in front of the 6. So my new equation is 2x minus 6 equals 2. So when you simplify, you always distribute first and then combine like terms second. So I'm going to combine like terms. Here's a 2x, there's a minus 2x. What happens? 0 x's, they're gone. So what do I have left? I have a negative 6 equals 2. That is impossible. So what do we say? No solution. You know what? Just for funsies here, I'm going to go back to the original equation or system right here, and I want to solve this using elimination method. Like if you really wanted to, you could make sure that both equations are in standard form, which the top equation is not in standard form. You could subtract 2x, subtract 2x. Let's rewrite that top equation. Negative 2x plus y equals 6. Now the bottom equation is already in standard form. Positive 2x minus y equals 2. Now if I decided to do linear combinations here because it's already ready to combine and cancel on the x's, but then the y's also cancel, I end up with 0 equals 8. And once again, if you end up with something impossible, what do you say? No solution. So I just wanted to show you that you could do it in any method you like. I mean, technically you could even graph it and see that they do not intersect, that they're parallel, right? So you could use any method you want. Of course, some of them are ready for substitution, some of them are ready for linear combinations, some of them are ready to graph. Let's go for this one. What do? Do you guys want to eliminate the x's or the y's?
The y.
The y's. Okay, if I want to eliminate the y's, I need to multiply the top equation by what? 6. Let's multiply the 6 to all of them. 6 times negative 2x, negative 12x. 6 times y, positive 6y. 6 times 3, 18. The bottom one stays exactly the same. But check out that weirdness. When I combine the negative 12x with the positive 12x, eliminate. The 6 and the negative 6y, eliminate. The 18 and the negative 18, eliminate. I end up with 0 equals 0. Now, is that impossible? No, 0 always equals 0. So what do we say there? When something's always true, we say IMS, infinitely many solutions. And of course, that's what it says up here on the notes, that if you end up working on something, or working on a system and you end up with something that's always true, like 0 equals 0, you say infinitely many solutions. If you're working on something and you end up with something that's impossible, oh, by the way, there's a typo right here. It says like 0 equals, it should be like 0 equals 5. If there's something impossible, you say no solution, right? So over here we got negative 6 equals 2. That's impossible. You say no solution. So that's what we need to be able to do, the goal for this section. Know which method to use. On Friday's quiz, I'm going to give you a 2-sided paper with a bunch of systems. And you need to know, oh, that one's ready to graph. Oh, it has the same b value. I already know the answer. Oh, those are parallel because if I think about the graphs, they're parallel. That means that it's no solution. Oh, this one is ready to substitute. The y's by itself. Or, oh, this one is ready to linear combinations as long as I multiply everything by -1. So you need to determine which method is best to use.